So, my name is Carlos Paez, and with my group Gabriel Gutierrez and Patrick Alexander, we chose numerical analysis project for the second project in our computer engineering 1331. So the numerical analysis is composed of two problems. Let's begin with the first problem. First, you let the user input a matrix. That matrix has to be n times n plus 1. That means that the numbers of rows has to be one less than the numbers of columns. Also, the first number in the matrix cannot be equal 0. If that happens, you have to switch the rows until the first number is not equal 0. The problem is composed of two user-defined functions. The first one is upper triangular form that transforms the matrix inputted by the user and makes every single value in the diagonal equals 0, and makes every single value in the diagonal equals a positive number, and every value under the diagonal has to stay 0. And then it uses this system of equations to get the solutions using back substitution. So if we go to the code, first your housekeeping commands, then you let the user input the matrix, and then you take the size, and then this while is to make sure that the user inputs an n times n plus 1 matrix. Then you begin with your first user-defined function to find the upper triangular form. This nested for loop is to make sure that the first value of the matrix is not equal 0, and if it is, it goes switching the rows around. This if statement is to make sure that the first value it's equal 1, and if that happens, you're gonna divide every single value in the first row by the first value to make the first value equals 1. This nested for loop is where you actually begin doing your converting your matrix into your upper triangular form. We first start down and we go up. So we transform this number to 0, that number to 0, that number to 0. And then we switch columns, and then we transform this number to 0, that number to 0. And it goes doing that until it reaches this value. Notice that these last two rows stay intact. That's the reason why your for loop ends at -2. The reason why this for loop starts at a row and -1 is because we start with the second for loop starts on the last row and it goes up. So you create a while statement to keep repeat the operations. Then if this condition applies, if it's equal 0, then apply this operation. If it is not equal to 0, you're gonna apply that operation. And if else, you apply that operation. Then this nested for loop is to make sure that every single value in the diagonal it's positive. Okay, once you have that, that makes the user matrix converts it into an upper triangular form. Then the second user-defined function uses the back substitution to get the value. So first you're gonna create a vector full of zeros with the length of the number of rows. Then you're gonna begin at your last row and going up, because you want this value first. You want to find the value of this first, and then you're gonna use this to get the value of here, and then you're gonna get this value, and then you're gonna input this value into this one and that value into this one to get this value, and you're gonna be moving up the matrix. And then you begin with 2 because you want to stop at this one, because this one is your last value that you have to get. You initialize a counter, and then you add it times this, you add it plus this, and then you input it into the vector. and those two functions will produce the the solution for the problem. Then the while makes sure that it asks the user again if he wants to input the matrix again. So if we input this matrix right here, which is a pretty large matrix, you see that it asks you whether you want again or not, and you can see that you have transformed this matrix into the upper triangular form, and you get the values. Okay? So now the second problem. Okay, so for your second problem, you're gonna let the user input a vector of values. Every single number of this vector is going to be an x number, right? Then you're gonna use this equation. Then you're gonna let the user input an up bound and a lower bound. And y1 is gonna be your lower bound, and you're gonna input this -1 every time you see an x. And your upper bound, you're gonna do the same for your upper bound. The multiplication of these two has to be less than 0. If it has to be more than 0. If it is less than 0, then you put a while to make sure that that happens. The idea is to get the bisection of distance of 2 points, and then reducing it by half, by half, by half, by half, in order to produce a function that looks like that, in which the distance always is reducing by halves. The distance of y's is always being reduced by half. Okay? In order to do that, we create two user-defined functions. So again, your housekeeping commands, your inputs, and then you begin with your user-defined functions. So your bisector rule begins this. So this is to calculate to input vectors. Then this while makes sure that the user inputs the vector on the dimensions specified. Then this while makes sure that the maximum error is less than the acceptable error inputted by the user. And then it calculates, it takes the first number plus the second number and then divide it by 2. And if that happens, you apply that. If this happens, you apply this. And then like that, you're going to get the maximum, you're going to reduce the distance by 2. You apply a counter to keep the numbers of interactions, and then you calculate the maximum error. Then for your bisector 2, your second function, your second user-defined function, again, you're gonna do these vectors, and then you're going to apply the while that we spoke here to make sure that this is always more than 0. As long as this is more than 0, then you're gonna apply this. This while also makes sure that the maximum error is always more than the acceptable error. So if that happens, you're going to apply all of these calculations right here until the acceptable error is more than the maximum error. Okay, and then you're gonna create your counter to keep the numbers of interactions, and then you're gonna input them here. Then you're gonna create this vector to approximate the root per interaction, and that should give you the answer. So now if we input this, if we input test cases, sorry. We're gonna input this vector. We're gonna input this maximum acceptable error, this lower bound, and this upper bound, right? And that should give us these two graphs. These graphs is interactions versus error. You see how the distance the distance goes decreasing by half. And then this graph is interactions versus approximate routes, in which it goes like this and like that. Well, this is all for the numerical analysis project. I hope you enjoyed the video.